Hello, my name is Christina Ovezik and I'm a PhD student at the University of Edinburgh. My research focus is on blockchain decentralization, and I'm part of a very exciting project for defining and measuring the decentralization of blockchain systems, which is called the Edinburgh Decentralisation Index, or EDI for short. If you don't know anything about this project, you might want to pause this video and take a look at all the links we have in the description, where you can learn a lot more about what the project's goals are and also what we have accomplished so far. Now, for the rest of this video, I want to focus on our open source repository for measuring decentralization on the consensus layer of blockchains, and in particular explain how it works and how you can contribute to it. Our goal for this layer was to determine the distribution of produced blocks across entities for various live systems, and then apply metrics on these distributions to quantify their levels of decentralization. So we started by collecting block data for different blockchains. We can see some sample block data here. And then for each blockchain, we also tried to collect some attribution data. That would be here, meaning any information that can help us map a block to the entity that created it. Remember that blockchain systems are pseudonymous, and it is possible for a single party to control multiple addresses, multiple identities in the system. So it's not trivial to determine who produced some block just by looking at the data we have on chain. So for each block, we can see, let's go back to some sample block data. So we can see some information such as the address that received rewards for that block, but then we need a way for mapping this to some real-world identity so that the distributions we end up with are not distorted. In essence, we are using a follow-the-money approach for determining the entities in the system, meaning that if we see block rewards going to the same place, we infer that there is a connection between them. So specifically, we employ 3 techniques for mapping blocks to the entities that produce them. First, we look at the block to see if it includes any identifiers that link it to a known entity. Mining pools and stake pools typically include some tag in the blocks they produced so that they can claim them as their own. So we can look for known identifiers like this in each block, and if we find a match, we assign the block to the corresponding entity. And if a match is then found, we also add the address that received rewards for this block to the list of known addresses for that entity. So here I just want to show you an example. So this is just a sample block from Bitcoin, and there is this tag that has been included in the block. And if we decode this, then we can see that the tag says it was mined by GB miners. So we can assign this block to the GB miners pool. And then also the addresses that receive rewards for it, we also assign them to those of GB miners. Second, if we can't find the entity using the identifiers, we also look at the reward addresses of a block to see if they match any of the known addresses that we have. And when I say known addresses, I mean addresses for which the ownership is known, it's publicly available. For example, if it's listed on some blockchain explorer, or if it has been inferred by the method I described just before. So, for example, if we look at this sample Ethereum block and we look at the address that received rewards for it, and then we go to Etherscan, we search for this address, and we can see that it belongs to Easel pool. So it's known, the ownership of this address is known, and we can then assign this block to that pool. And if we do find that a block has been created by a known pool, then we also want to check if that pool is part of a larger cluster of pools. And when I say cluster, this would be a group of pools that are operated by the same entity, the same organization, let's say. So sometimes it's not sufficient to map the block to the pool that produced it. We also need to map it to the, let's say, parent organization, if this is the case, if we're talking about a pool cluster. For example, if we look at this sample block from Cardano, this one, we can see that it has some metadata telling us that it was produced by the stake pool with the ticker 1PCT5, but then we can tell that this is actually part of a cluster of pools. In this specific case, it's the 1% pool cluster, where, for example, if we scroll down on their website, we can see that they control a number of different pools, and 1PCT5 is one of them. Another example of this, like cluster or like links between pools, would be if we see a block, let's say on Bitcoin, that was mined by btc.com after April 2021, April 15, we would actually map that block not to btc.com, but to Bitmining, because of the acquisition that happened at the time. So yeah, it's important to go, let's say, to the highest level of the hierarchy that we can go to. Of course, this process I just showed you here was just to make you understand how what our reasoning is, but it's not like we manually go to check all these websites for every block. This is automated in the code, and this is what this mapping information is for. So we have all these different data files that for each mapping method I mentioned, we have one or more corresponding files that give us information that can be used to automate this mapping process. And these files were created using a combination of automated and manual work, and they're a very important part of our tool. And actually, let me go into some of them so that you can see some examples of what I mean. So let's look, for example, at this file, which shows us known addresses for Tezos, for the Tezos blockchain. So if we see some block that was where we know the address that received rewards for it, we can check if this address is in this file, and if it is, let's say if it was this address, then we would map this block to fresh Tezos. And note that for all these files, we have a source, and this is a very important part. So for each entry, we require a source so that it can be verified by anyone that this information holds. And when adding a source, we want to make sure that, if it's a website, we want it to be active, we want it to be public. If it's some unofficial tweet or private source, it's not considered a good source and it could be rejected. So yeah, this was just to show you an example of an addresses file.
then perhaps we can also see an example of some identifiers, like the tags I mentioned. So this is an example for Ethereum, where what this tells us is that if we see in some block, specifically for Ethereum, I think this would be like the extra info field, but in general, what we call identifiers, if we see the word Ethermine, then we map it to the pool Ethermine. This is pretty obvious, but some of them, like if we see these Chinese letters, we map it to F2 pool. So we have all this sort of information for many different entities. Then another example I can show you is some cluster information. This is from Cardano. And for example, what I was talking about before was the 1% pool. And here it has a slightly different structure, the file, where we have a pool ID, the hash of each pool, like some identification, and then we say which cluster it belongs to, what the name of the specific pool is, and the source here, it could be some link, but what we say when we say homepage, we mean that all the different pools in that cluster share the same homepage, and that's how we deduced that they're part of the same cluster. So these were some examples so that you can understand what I mean when I talk about these files. But now I can also, I'd like to show you how you could contribute to these files, because we understand that the data that is currently here is by no means exhaustive, and we welcome contributions from anyone who may have a more accurate picture of the entities in some ecosystem. So if you have any information about pool identifiers, address ownership, or clusters that is missing, you can open a pull request to include this information to this EDI tool. And we appreciate that not everyone is very familiar with GitHub, so I will briefly go over the basics of creating a pull request in this project and just show you an example of what a possible contribution could be. We can do this in a few different ways. I'll just show you how to do it online using the GitHub editor for the people who are not too familiar with Git. So let's suppose that we have some information on the ownership of some address for Ethereum that is not already in the public repository files. So we'd start by opening the right file. We would go to the mapping information, addresses, and then Ethereum. And then we would click on edit. So specifically because you wouldn't have write access to this repository, so it would ask you to fork the project first and then edit the file. So you would click on this and again fork this repository, and now you've created your own fork of the project, your own version of the project for your GitHub account, and now you can edit the file. So here, for example, let's say we want to add a new address. So now I'm going to, this is not the real information, it's just an example. Let's say there is this address, which is not valid, but let's suppose that it is address 156, and it belongs to some entity by the name Christina Ovezik. And then the source, as I said, we need to add some source, and let's say that this source should be etherscan.io. Good. So what this means is that if someone goes to etherscan and they look for this address here, it should show them that it belongs to Christina Ovezik. Yeah, obviously it won't in this case, but just telling you how it should be. And then what we do is we click on commit changes, and we add like some short and descriptive message. It could be add new Ethereum address info. That's good enough. If you want, you could add more details, but it's not necessary in this case. And we click on propose changes. And here we can see the changes that we made. So you can see the lines that were changed. If we had changed more files, we could see all those files here too. And then we just click on create pull request. So here we would add a title to our pull request. I'll just keep this as it is. And then we also need to add a description. Let's say we added information, address, ownership information for an Ethereum address. That should be good enough. And then we see that we have a pull request template here. So we're going to keep from this checklist what is relevant to our pull request, and we're going to remove the others. So we didn't add support for a new ledger, so I'm going to remove those. Right? Yes, so I'm going to delete that. We didn't add any new metrics, so I'm going to delete that too. We did update mapping support information, so we leave this here. And here we have Ethereum. We updated addresses, and we didn't need to update the tests. So yeah, I guess I'll do this. And then we click on create pull request. We have followed the guidelines in our contributing documentation, but we should open this just in case. You might want to take a look at this. It is pretty much what I described, at least for the mapping information, but if you want to contribute some other way, it would be good to read this and in general go through our documentation if you have any questions. And we haven't verified that there aren't any open pull requests on this, so we could try doing that though. Okay, we see there are some pull requests, but none of them. This is ours. None of them, none of the other ones is about adding address on Ethereum, so we're good. And then for the tests, we don't know if they pass yet. We'll have to wait and see, but they should. So that's it. We see that there are two people, Dimitris and myself, who have already been asked to provide reviews. So after that, one of us, like a member of the EDI reviewing committee, will review the pull request and will either approve it and merge it to the code, or ask for clarifications or changes if it needs to be updated. And that's it, really. I hope it's not too complicated. I am actually going to close this pull request because it was just an example, but in general, this is the way it works. I hope it's clear, but if you have any questions related to what I showed you in the video, feel free to post them in the comments. Thank you.